All right, let's get started. Welcome, everybody. So when the summit call for papers went out, one of the things you could put on there was not just things you wanted to present, but maybe things that you wanted to hear about. And one of the things that came through was people wanted to hear about what the vision for 2.0 was. And so we decided to put together this little presentation here. I'm John Bellameric. I am one of the SIG chairs of SIG Architecture, and got a bunch of other people here who I'll introduce in a moment. But so, is everybody ready for 2.0? Everybody? Woo! All right. Look at that reaction. Well, realistically, we're not ready either. In fact, I'd say that a lot of the work that we've been doing over the last really few cycles is around maturing the product. If you look, that means getting stuff to GA. So this is a slide that might look familiar to some of you. It's from Brian's Grant's keynote at KubeCon 2 years ago, was it? And you'll see that some of the things that used to be V1 Alpha 1 and all of these things in the core, they've all evolved to V1. So we've managed to really move the product forward as far as bringing things to GA. But we're doing a lot of other things too to try and bring more maturity to the whole platform. So things like API reviews, which Jordan runs. There's been a huge focus on extensibility, as we know, with CRDs and webhooks and other things, pluggable interfaces throughout the system. We've got work going on in conformance, code organization, production readiness, tech debt. So a number of these things will be talked about throughout the day today. If you're interested, Hippie Hacker will be coming up right after this session talking about conformance. And I'll do something on the production readiness effort we're working on. And I guess there's an unconference on tech debt. And of course, Jordan is doing an API review later for a workshop. So moving along, I have to say, not ready isn't quite the right thing. More accurately, we just don't think we really need a 2.0. And the reason is because of a lot of that work that I just mentioned. So there's been a big effort here on that extensibility aspect. And that allows us to really evolve Kubernetes in pretty dramatic ways, adding a lot of functionality, changing existing functionality in a way that doesn't break backwards compatibility. So the decoupled architecture that we have between the APIs and the controllers that express them, and the independence of each API that are relatively independent from one another, the API groups and kinds that we can structure, allows us to really advance the state of the art without breaking things. So what we're going to talk about today then, instead of the vision for 2.0, is some of those design patterns that are used, some of the things going on within the overall project that allow us to do those advancements, and some of the new functionality that's really pretty dramatic changes that can happen without breaking things. So to start, we'll have Jordan talking about extensibility. Thank you, Jordan.
All right, so one of the big things that was in the core, in the nucleus, that was listed as beta for years and years, actually, was custom resource definitions. And as of the last release, so 1.16, this reached GA. So this is now a stable API that you can write against. And it's also been added to conformance, so that any conformant 1.16 Kubernetes distribution and up, you can count on this capability being there. And so this is really essential for enabling what John talked about, building things on top, like keeping this core stable and compatible, and enabling experiments and evolution and sort of the next generation of things to be built on top of that foundation. And so this is just sort of a bullet list of capabilities that have been added over the last 2 years to bring custom resources up to parity with built-in resources in a lot of ways. So things like validation, being able to express constraints on your types and be sure that the data that you're getting in and out of the system is well schemed. Best practices around status subresources, scale subresources. The ability to have multiple versions, so to have an alpha custom resource and then promote it to beta and promote it to V1 as a signal that it's stabilized and is ready for consumption. Or if you need to make schema changes, the ability to wire in your own conversion logic via webhooks. Things like dropping unknown fields so you don't end up with time bomb data persisted that your controllers have to deal with later. And then in the current release, the ability to add defaults for fields. So if you have a new field you introduce that makes some previously implicit behavior explicit, you can take existing persisted data and make that explicit behavior be defaulted so that when people read those prior objects, they see this new field. So this is all sort of matching capabilities that we've had in the built-in APIs over time. And then you can see there's still work to do. There's still things we want to add. The ability to mark a field immutable once you persist it, so that as you're writing components to take custom resources and sync them out to external systems, if there's an attribute that can't actually change, you can make that part of the API so that you don't have to write as many webhook admission plugins to enforce this logic. Things like tooling improvements, integrations with Cube Builder, all of these are ongoing things that will bring down the cost of building on top of custom resources. And so you might ask, why did this take 2 years to do? It's a good question. This is a great diagram. Stefan put this together as part of the defaulting work. But this is kind of an illustration of the pipeline inside the API server. And a lot of the work over the last 2 years was getting the custom resource pipeline to line up with the pipeline that we have for built-in resources so that we could have all of those lifecycle hooks, validation and defaulting and conversion, and have these things work consistently and coherently between them. So tons of action under the covers. From your perspective, what it means is you can now write custom resources and they inherit most of the capabilities of built-in resources. So I mentioned webhooks. That's the other piece of the extensibility story in Kubernetes. The ability not only to persist, kind of do basic CRUD operations on blobs of data, but also to hook in logic, whether it's to your custom resources or to in-tree resources. And so admission webhooks also reached GA in 1.16, and that also took years and years to get to GA. And a big reason was we were listening to people using the beta functionality. So we got the beta version out there, and then people started using it and said, well, this works great, but this doesn't work great, or when I intercept this resource, it does something weird, or if I've got two mutating webhooks, how do I make sure like they run in the right order, and how do I run in the right order with other unknown things that might show up in the future? And so all of these stories were feeding back into the work we were doing. So this, again, is a list of things that have showed up in the last several releases to address real-world problems or constraints or limitations that people found. And so one of the two that I'm most excited about are the ordering thing. So anytime you talk about extensibility, coordinating extensibility becomes really difficult. You know, you've got lots of people writing to Kubernetes as a target platform, and they don't always know about each other. And so anything we can do to reduce couplings between components is beneficial. And so as of 1.15, 1.15 or 1.16, I forget, so long ago, you can indicate that you would like your webhook to get called again if someone else changes an object after it saw it on the way into the API server. And so this reduces the ordering dependencies that you have between components. This works for in-tree admission as well as out-of-tree admission, webhook admission. And then the other thing I'm excited about is the API server will now convert objects into a version your webhook understands. And so if you understand apps v1 deployments and you've got a webhook that you're super happy with, you don't actually have to keep up with every single release and pay attention if a new beta version of deployments shows up. You can tell the server, hey, I understand apps v1 deployments. If someone submits a new beta version, convert it to a apps v1 one and send it to me. So this reduces the cost of maintaining a webhook over time. You can really just target the stable releases as they show up. And again, this API is v1 in 1.16. And so this is ready for use. All right, I don't know who's next. Rob.
All right. So as far as SIG Network, we've been working on a couple changes to key resources that networking cares about. So with SIG Network, we obviously care a lot about Ingress. And Ingress was really a very, very basic system. It was designed as good enough for a lot of users, but unfortunately not great for every single use case out there. So it was great in solving a lot of the most simple networking issues, but unfortunately, it didn't solve everything. So with Ingress, we've decided to create this new set of resources, gateway class, gateway, and route, that will help provide an alternative to Ingress. Ingress will continue to be an option. It will continue to solve a wide variety of very simple routing use cases, but for some more flexibility, for some more options, we've provided a new set of resources that should give us more options. This is very much still in a proposal stage. If you're interested in Ingress, if you're interested in talking about this more, definitely reach out to someone in SIG Network. There's another talk about this, I think, on Thursday. And definitely at Meet and Greet, come talk to someone at SIG Networking. We'd love to hear how we should do this if our proposal as it exists right now makes sense. Now, one of the key things about these new types is we're able to use CRDs. Because of all that stuff that Jordan mentioned, CRDs are really powerful, and they should work very well for these new resources. So instead of adding a whole new set of built-in types, we're able to provide this with custom resources. Another big effort underway in SIG Network is that of Endpoint Slice. And to understand Endpoint Slice, you have to understand some of the limitations we ran into with endpoints themselves. So endpoints are those resources that sit behind services and represent all the backends, all the network backends for a given service. So every pod behind a service will map to a single network endpoint. The problem is that every single endpoint for a given service has to sit inside a single API resource. And as you can imagine, that works great until it doesn't. At a certain scale, and that scale is relatively large, but people are building larger and larger Kubernetes clusters, you start to run into issues. What we found is around 5,000 endpoints behind a single service, and the actual endpoints resource starts to get just too big. It runs up against a etcd object size limit, as an example, a variety of different issues. And just by the very nature of endpoints and how we work with endpoints, every single node in a Kubernetes cluster is watching these endpoints so kubeproxy can work. So you take one single endpoint, change a pod change, when you have that huge kind of service, and you're transmitting maybe around 5 gigs worth of data for a single pod change throughout your cluster. So it can get really significant at scale. So the idea was, well, why can't we just split this up? And with Endpoint Slice, we take those endpoints, we slice them, and make many smaller resources instead of one single huge endpoints resource. So endpoint slices and endpoints will run in parallel. The whole idea of we don't need a V2 is simply that endpoint slices can continue to exist, can run and provide this great new functionality and scalability while still letting the endpoints API exist for as long as it needs to. We'll slowly move in most use of the endpoints API over to the endpoint slice API, but the endpoints API will continue to exist and provide great backwards compatibility. And that endpoint slice API is going to ensure some really nice new functionality. You can scale way beyond the limits of endpoints before it, and it adds some new functionality. And we're able to do this because Kubernetes is this great platform for extending APIs. And finally, endpoint slices are actually not built with CRDs. And this is unfortunate, but one of the key things with endpoints and now endpoint slices is the API itself, the API server, when it starts up, needs to create a resource to refer to itself so that other components can actually access the API. So it's hard to justify a custom resource for something that is so core that the API server itself needs to create it to refer to itself. And also, because these resources are being sent across the network to every node so frequently, protobuf is really important because it provides a very significant performance improvement at that scale. And unfortunately, at this point, it's not supported yet for CRDs. So that's endpoint slices and Ingress. I think Paul might be next.
Okay, is the mic on? All right. Hey, everybody. So SIG multi-cluster, why does it matter? The answer, in my opinion, is that almost every non-trivial user of Kubernetes is eventually going to have multiple clusters that they need to manage at scale, make work together, et cetera. So in our current and prior work, I'll just quickly give you all a rundown of what we've done so far. There's the cluster registry, which is an API for inventorying clusters. There's KubeFed, also called Federation, and it is about spreading API resources from a single API endpoint to many clusters. There is some work that we've started doing on a notion of cluster ID, which would be a permanent coordinate for clusters that's longer lived than a particular cert or DNS name. And then also some folks in the community are beginning to work on a project called Submariner, which is about providing network connectivity between pods in different clusters. You may notice if you're looking at the slides that almost all of these things are alpha or they're just written down on paper and don't have code behind them yet. Now, if not for the extension mechanisms that Jordan talked about, I'd probably have a lot less to talk about because CRDs enable you to do a lot of things faster than if you have to write your own API server, which I have done, and I do not recommend it. But that low API maturity that we have here is actually an asset to us because it means that we have the flexibility to think about what is best to do, to explore new areas, et cetera. And we're in a situation now where there really aren't widely accepted primitives in our project. So again, opportunity there, chance to establish those primitives. So those areas to explore look like inventorying and grouping clusters. Like if you have a fleet of hundreds or thousands of clusters, probably just an unstructured list isn't good enough. There's also the concept I touched on a little bit earlier of cluster ID. Connected with that, who owns clusters? What does authorization and authentication mean in large groups of clusters? And then many different areas where you can think of parts of the existing Kubernetes API that deserves some thought in a multi-cluster context, like namespaces, service accounts, different types of workloads, network connectivity, like many different aspects of networks, fully connected, partially connected, disconnected clusters that you still want to manage somehow, storage, of course, and then how do resources get to those clusters and how does work happen on those clusters? So if you're interested in this, actually this is a slightly out of date version of my slide, that's okay. If you're interested in this stuff, we'd love to have you, and we're gonna do a intro and deep dive talk later this week on Thursday, so love to see you there. I think it's you now, Yuju.
So you have already heard a lot of examples from the previous speakers. So I'm just going to quickly go over some of examples in the Signal that we have seen. And one of them is that in Signal, we constantly get requests about adding and supporting a new runtime environment. And with each new container runtime environment, there comes a lot of configurable knobs and requirements. It's simply not sustainable to directly expose them through the Kubernetes API. And also, it's not really that user-friendly to ask user to configure each and single one of them. So what we've been doing is that we introduced Runtime Class, which is a built-in resource that is another abstraction layer to abstract away the problems. So right now, the cluster admins can actually configure runtime the way they want it, and with different runtime handlers. And then they can define and create those runtime class resource objects. And users can specify which runtime class to use in their specific path specs. So this is all you need to do right now to use runtime class. It is a built-in resource since it's also pretty core to the Kubernetes API. And if you don't specify anything, then it will default to the default runtime class, which is the same as the days before the runtime class exists. And besides projects that require introducing a new resource type, we also have a lot of projects that just focus on extending through other mechanisms that is within the node area. For example, the container runtime interface and device plugin, etc. And usually, those projects would require also to evolve the Kubernetes V1 API by adding new fields that are backward compatible. So one example is the ephemeral container, which is a new type of container you can add now in the path spec, so that this container can be added dynamically to a running pod, which is really useful for troubleshooting distro-less containers. And there are a lot of ongoing projects that have been discussed in SIG Node every week, which more or less follow the same pattern, like sidecar containers, in place update of pod resources, etc. And if you are interested in discussing and learning more about them, or just interested in the SIG Node in general, feel welcome to the SIG meet and greet this afternoon. Thank you.
All right. Thank you, everybody. We have a few minutes for Q&A, if you want, from any of the people here. All right, no questions. Awesome. Okay, so thank you. The point here was that we have these patterns for extending the system, avoiding the need to go to a 2.0 anytime soon, we hope. And let's take a little break before the next in this room is Hippie Hacker. He's up at 10:05, I believe, so we have about 10 minutes. Thank you.